Hello guys. Today's video is about Newton's law of motion. So, without wasting any time, let's go into Newton's laws of motion. Yeah, it has got three laws: one, two, and three. And I'll be dealing with these three with the introduction, as well as I'll try my best to help you with understanding it with more depth so that you don't have to memorize the statement again and again. So, with a scenario, it will be better to make you understand and remember those things. So, let's come to first law. In this case, you'll have to imagine a body which is at rest, and when we mean at rest, that mean the body does not change its position with time. Okay, the clock's been ticking and the body is not moving anywhere, its position does not change. That means the body is at rest. Here's another scenario you have to imagine a body is moving in a straight line with a uniform motion. That means the speed is constant speed along with a fixed direction. So this is suppose you build a system like this. There's nothing else here but a body that is at rest and another one is in uniform motion. So the body at rest will be like this, as well as the body which is at in uniform motion will be like this, until and unless an external force applied. This external force comes into this system and disturbs these two states. The state of rest has been disturbed and the body goes to anywhere by changing its position. Suppose if I pu- put it up and I threw it away, so at that time it's no longer at rest. It did not maintain its position with time. Okay, and here in this case, suppose I applied this force at the body here. It was supposed to move here, but it changed its direction along with its speed. Okay, so the statement is about this scenario is that a body, whether it is in state or in uniform motion in a straight line, will be like in that state or will maintain that state until and unless there is an external force applied on them. So you have heard of some of the things that you might have used in this scenario. One is inertia. These two are at this condition. This is a inertia at rest, inertia of motion, and due to inertia they will be maintain their condition, but the external force comes and disrupts them. And what do we get from Newton's first law? What do we get? We get the definition of force. And what is actually definition of force? Well, force is an external cause. External cause, as you can see from this scenario, is nothing but an external cause. And what did it did? It disrupted their states. Yes, it's an external cause that changes the state of motion or rest of a body. Okay, now let's move on to the next one, which is second law. And what is second law? here in this case you have to look at this. The statement says that the rate of change of linear momentum is directly proportional to the force applied, and the body moves in the direction in which the change in momentum occurs. For this, you just have to imagine a body with two stages. One is the initial and one is the final. Initially it has u, v. Mass is the same, okay? Mass is constant, right? But its velocity is not constant here. It changed from u to v in time t. So in time interval t, velocity changed from u to v. And why did it happen? It happened because of the external cause. And which is our external cause? Yes, it's nothing but force. Force applied on it did this. So as you know, suppose it was moving from u, and there was force applied. So what if the body moved in that way and force applied in this way, in the same way? So uh, it's obvious that v will be greater than u, right? So body will move in that direction with more speed, right? So this is what all about the second law. It states that the rate of change of linear momentum is directly proportional to the force applied, and the body will move in that direction in which direction momentum changes. The momentum change is done in this direction. The change is in this direction. Okay. This is the reason why it moved in this direction. So F is equal to ma. This is what came from this. I want to let you know something about momentum. Uh, as from the book, you have read that momentum is equal to mass into velocity. In many books, I have read the definitions be like momentum is the product of mass and velocity. But let us have a look at this in a more practical manner. Here's a body with mass capital M, and here's a body with mass small m. It is a velocity v, is a velocity small v, okay? The momentum of the bigger one will be mv, and the smaller one will be small m into small v, okay? Fine. So you can imagine a few scenarios. So the first one is that just see these two balls approaching at you with same velocity, but which one will be more harder to catch? Yes, the bigger one, as it has the greater momentum. So, but what if these two have different velocities? If what if this v is much greater than v, then it may be possible that you will find harder to catch this one as compared to this one, as more force or impulse will be needed to catch this one because of high momentum. And since there will be more momentum change in less amount of time, so impulse will be very high, so you might get your hands hurt by catching this one, as just because of its velocity is too high even if its mass is less. So in this way you can perceive momentum. Now let's move on to the third and final law. What does it say? As you have all read the statement that every action has an equal and opposite reaction, but here's a scenario you can imagine. Here is a body having mass m. Take another scenario, a ball having a certain mass, it is falling. Here is a case of free falling, okay? And in this case of free falling, you can see that it's going downward due to the force acting on it. Weight is the force, right? Weight is nothing but a force. Weight is equal to mg, mass into acceleration, which we got from the second law. Second law. And also from second law, we know that this is used to measure force. So we get the measurement of force from second law. But now, as we are talking about third law, we'll be dealing with action and reaction. So here in this case it's falling down. Here is also in this case weight is acting downward. But why is this body not going to the center of the earth? As gravity acts towards center, then why is it at rest? Yeah, there is, you can see a surface. Many of you can say there's a surface resisting it. Yeah, but there's, what is the thing that actually resists this one? And the answer is the normal reaction. Normal reaction is a force that is normal to the surface, and it comes in a reaction to another force. That's why this is called normal reaction. Okay, so the body is in state of equilibrium because n is equal to w. So a body will be at in equilibrium even if there are multiple forces applied on it. The body will be in the state of rest if those forces have resultant 0 after adding. Yeah, and this addition is vector addition. Suppose there are f1, f2, f3, f4, f5 and f5 also, okay, plus f5. So these forces have a resultant of 0. That means the body is in equilibrium. Equilibrium is a word that came from two words equi and librium. Yeah, it's good to understand this by their etymology so that you don't have to memorize these words. You can just see this and understand what does it say. Equi means equal and librium came from libra. That libra is balance. Yeah, the common balance that is used to measure mass. Okay, so equal balance is what going around here in this case. So apart from this normal reaction thing, we have several other cases. Like you can see there is a string and there is a body, and this string is attached to a rigid support and the weight is acting downward. But what is the force that is balancing this? Yeah, this is nothing but the tension in the string. Right, this tension here is the reaction force to this. So here this is action and this is our reaction. So I hope it gets clear to you. So thanks for watching and please subscribe for more videos. Like, share and comment, and let me tell about you that if you have been dealing with any issues in any kind of topic, so I can help you out by uploading more and more videos, so please support.